Okay, welcome to the Transparency BoF. I would suggest that we first go through and you quickly state what you're interested in or what you personally would like to talk about, and then we'll try to form an agenda out of it. So yeah, please, can we start at can we use the portable mic for people to say that? Okay. Can you just give it to some person and that poor person has to start? Oh, and before I start, could I ask somebody to go into the IRC for this room? So if there are any remote questions or topics, we could hear those. Is anybody on IRC? I think the that's great, awesome. Thank you very much. Yeah. Okay. Yeah. So.
You want to? I had to tell why I'm interested in transparency.
If there's something you'd like to talk about, or why you're here, just very briefly.
I just curious about reproductive builds, and that's it. No,
okay,
not
yeah.
just.
Yeah, give it to the next person, please. Yeah.
I'd say I'm curious about things other than reproducible builds. So about what is reproducible build, we do know something. About other techniques with software transparency, we still don't know. That's it.
Thank you.
Well, I'm here just for just to get to know about the talking and stuff. So I'm just curious. Anyone?
Okay. Then perhaps. My question would be, are people interested in doing a short architecture recap? So we go over the architecture once again and clear up a question or any, perhaps you have some ideas you'd like to bring forward. Okay, so this is the way that the archive works right now. So we have the uploader signing her source package. The archive takes care of it being built and signs all the packages that should be included. The mechanism is that we have a file called the release file, which essentially contains all the hashes of all the packages, and this file is then signed by the archive signing key. And afterwards, this release file, all the metadata and the packages are put onto the mirror network, the content distribution network, and the clients can install it from there. So this is really well because it authenticates all the packages. However, the security depends on the single archive signing key. So when that's compromised, all is lost, and we don't have any other security mechanisms. So the proposal here is to add an additional component called a log server, and the function of this log server is that it provides an append-only data structure, and the reason why we do that is we try to create one globally unique view on the archive, so such that it can not be possible that a compromised archive presents two different versions of the release file to two different people, right? So we want there one globally unique view, and once we, if we can achieve this, we can exploit this globally unique view for other purposes. So, for example, we could check that the archive has only included packages that build reproducibly and hold it accountable accordingly. Okay, so this is the core idea. We want this unique view. For this, we have a log server which maintains a hash tree over all the metadata and source code that the archive ever issued. So if anything's unclear, please just feel free to interrupt me. We just have to take care of the microphone. Who has the microphone right now? You have it. Okay, so just raise your hand, please. All right. Yeah.
What if the compromised archive presents correct files to log server, but to all others it presents another file?
Yeah, so the way that we detect this is the following. The log server provides proofs to the client. So the client, in our case apt, needs to do some additional checks. And one of the checks that it does is the first one here. It checks that the release file is included in the log. Does this address your question? Yeah. Okay. So so the log server and the client need to communicate, but the good thing is the content of this communication is known. So we can have the log server prepare it basically in advance and put it onto the mirror network as well. So right now the idea is that we can, for example, for the time span of 1 year, put all the required proofs on the mirror network. It's not too large, it's not too many files, and then only if I haven't updated my computer in say over a year, I actually need to have additional network traffic and contact the log server directly to retrieve those kinds of proofs, such as the inclusion of the release file. Okay, a second check that the client does against the log is to check that the log provides us with a consistent history. So the log server maintains its list of release files, metadata, and source packages append only. So there is no manipulation of the history going on. Okay, so that satisfies the needs of the apt client, and then we are not quite done yet, because all we have done so far is we have checked that the release file from which we determine the packages we can install is actually available in the log server. We haven't checked yet that other suspicious things aren't going on. So, for example, we haven't checked anything about the reproducible builds property. But now that we demand that all the package hashes and the source packages are included in this log server, we can go through this log server, which is what the monitor does. It goes through the list maintained by the log server, and it will check a number of things. For example, it can verify the reproducible builds property. And the great thing is, once we can do that, we can provide an additional assurance to the users. Namely, we not only promise that the archive provides reproducible builds, we also have a additional check that is able to by going through the log server is able to actually inspect all the packages and all the package versions that were ever or are published by the archive, right? So we don't just query a mirror, retrieve the packages from there and check reproducibility. We rather check that we rather go to the auditable list of all packages, which is contained in the log server, and check there that we can reproducibly build all the packages. Okay, so the monitor is pretty important here to do these kinds of checks. The monitor also has to do other checks. So, for example, it also checks that the log server maintains the cryptographic invariants, such as maintaining the list of release files and source packages and so on in an append-only manner. Okay, so what questions do you have so far regarding the architecture?
So you're trying to solve a problem.
Yeah.
So I didn't quite understand what problem this design tries to solve. Is it that you are afraid that the archive signing key might leak, and you have two different binaries that are signed with the correct key?
Yes, so compromised archive is certainly one of the core concerns that we have. So first of all, what we want to do is we want to make sure that everybody has the same view on the archive, because that takes care of an attack, or then we can detect an attack where a compromised archive tries to attack a certain subset of Debian users. Okay. Does it make sense?
In my idea, the solution should be something on the client side that the clients can, in a peer-to-peer fashion, share what they are seeing.
That's certainly also a possible design approach, but it brings other difficulties with it.
So now you are trying to add two places of trust, the archive and a separate log server, and then assume that those people who have access to compromise the archive key would not be able to compromise the log server.
Yes, so that's a very good point. The good thing about the log server is that we need not trust that it operates correctly, because we can verify the correct operation from the outside. And the mechanism that's used to do that is the hash tree that the log server maintains, because then it can provide proofs to the client. So, for example, if a client wants to ensure that the release file it observed on the mirror is actually contained in the log server, the log server can provide an efficient cryptographic proof of that fact. So we needn't trust that what the log server does is correct. We can check it from the outside, or ask the log server to prove it to us. So the log server is generally assumed to be benevolent in the sense that we think it tries to cooperate, but we don't trust it from a security standpoint that it is always benevolent. So if it acts in a malicious way, we would need to detect that. Does that help address your concern?
Yes, thanks.
Yeah, welcome. Okay, what other questions regarding the architecture do you have? Yes, so could we get the microphone over here, please? Thank you.
Checking this picture, the metadata will only go to the log server, or the client side will take this metadata to check the how can I say, the consistency of the archive on the apt server. This metadata go to only to the log server, or go to the client too?
The metadata here is the existing metadata. This means the in-release file, the packages.xz file, and so on. All the stuff that you find on the mirror. These are the metadata files I'm referring to here, and these are also downloaded by the client, of course. If you do an apt update, you download these metadata files, and then apt will tell you I have these packages available. And so these are the files that are submitted into the log server, and the client will now check that the release file here is included in the log server. Welcome.
Just another question about software transparency. It's about how we can detect the situation when maintainer decided to become a bad guy. When
Decided to become, sorry?
a bad guy.
Yeah.
He decided to inject to the source package any obfuscation code which doing something for what he received the money.
Mm-hmm. Okay, so if a malicious maintainer submits this malicious code in source code, and we just compile the binary from it, there's nothing we can detect. What we can do is attacks where the source package and the binary package don't fit together because reproducible builds doesn't work, for example, or because the binary package was manipulated in some way. This would be something we can detect in this design.
So we don't have any monitors or detectors which can detect this situation.
Well, the fact that software is malicious is nothing that we can detect. We can only detect misbehavior in the updating or in the release infrastructure.
My question not for maintainer base project, but for the maintainer of the package. So we don't have any detectors which are compare base mainline project in open source and which changes maintainer done in this package.
I'm sorry. I'm afraid I don't think I have quite understood the question.
For example, we have Gym project, open source project, and we have maintainer, Debian maintainer, which supported this project. Can we detect situation when Debian maintainer does changes in the source code which are not fit to the mainline open source project.
So let me rephrase the question to make sure I understood. So your question is, as an upstream, can I check that the Debian maintainer hasn't done any modifications?
Yes.
Yeah, okay. So in this model, the way that it would work is the following. You run one of these monitors that retrieves all incoming releases and incoming source packages, and you have it watch for your package specifically and check that the source code matches what you expect it to be. However, in a Debian package, the maintainer can also add patches, for example, or there can be maintainer scripts which do some manipulation of something. They can do anything. So if these are present, then you would need to check them by hand. But you can, the fact that the source code itself looks different than your upstream release, that's something you could verify.
So it's manual operation, yeah? No automation detection.
It depends. If the package is very simple and there are no Debian maintainer patches and no scripts that can manipulate anything, it can be done automatically. And if that's not the case, then you have some code that does something, and this will always need manual inspection. But you could, for example, be alerted once this is the case and acknowledge the check. Yeah. So that's something you could realize with this system, but it might not be a core functionality or goal. Can you hand over the microphone, please?
So related to this, there's one check that we don't currently have. So that if source code, so if the Debian package does use Git or some other source control, and then something is uploaded, but that was not committed to the source control, then there's currently no check on that. There's a check on tracker that if you have commits that have not been uploaded, but the other way around, there's no check currently. And
perhaps we should still have the copy somewhere.
And this is a security issue, and it's also a quality issue that it's packages that have source control still might get manual uploads by somebody. That's so not stored in the source control.
Your concern is that the Debian repository might not be reflecting what's currently in the archive. Is that correct?
Yeah, the Debian packaging repository for a single package might not have everything that was uploaded to the archive.
Okay. Yeah. So that's a case I haven't considered so far. So I've written it down as something we.
You could, for example, if you're using Git build package, which always tags what you uploaded, and you could compare that exact tag to what is the source uploaded to the archive, if it's the same or not. Currently, there's nothing checking this.
Yeah, that's a great idea. Okay. What other questions do you have regarding the architecture proposal?
So who's going to maintain this log server?
Yeah. So the log server would be something that is operated within Debian, because it needs to be reliable, right? So the archive is submitting stuff into here, getting back the proofs that it wants to put onto the mirror network. So it needs to be reliable, so we would need to maintain it. Yeah. So right now in the implementation, what I've done is I've used the Trillion generic log server and written a front end. So we have a MariaDB database that stores the Trillion information, and an HTTP front end that speaks a simple protocol. And there is also another daemon that's provided by Trillion, which takes care of sequencing and signing stuff. Yeah, so I'm running a log server that I'm feeding from the Mirror network. So the main thing it does, it's growing in disk space because source packages, new source packages are added sometimes. Yeah, otherwise it's relatively unspectacular. Mm-hmm. Yeah, please. Feel free to hand around the microphone yourself, so that.
Could you give more detail? How does the log server cryptographically prove that the archive is correct? The client only has one key or several keys for the archives, right?
Yeah.
And if that key is compromised, how can the log server prove anything?
Yeah, so we need to be very careful about what we assume the log server can do. So first of all, the client here also knows a public key of the log server, so the log server can sign stuff. And the stuff that it signs is most importantly the root of the hash tree. So if we look at the list that the log server maintains, our squares here are things like the release file, packages.xz, the files that make up the source packages. And we now, the log server now constructs a hash tree over this. So the label of each inner node is the cryptographic hash of its children. So if we know this hash value here, the root hash, we can identify all the items that make up the lists, right? Okay, so what is done now is the log server signs this root here, and thereby it states, okay, for this list size 8, I think here, I have computed this root hash, and I'm going to sign it. So everybody who sees that root hash can hold the log server accountable. This is what the log server says at generation 8 were the elements that make up the list. And the thing that the one of the things that the client can do now is to ask the log server, can you please convince me that this release file I have here is actually contained in this list, meaning it is present in the log server. And the log server would do that by providing these 3 nodes marked in gray here. And using these 3 nodes, the client can recompute the root hash and thereby convince themselves that yes, the release file here is actually included in this list. So this is the kind of thing the log server can communicate to the client. Does this help you understand?
So the client has a separate key for the log server.
Yes.
And if that key is compromised, then this mechanism doesn't work anymore.
If this key is compromised, well, the question is what is the attack that is happening with the compromised key?
I'm asking who is maintaining the log server.
We make up a fake log server that tells that our compromised archive is okay. And the client must maintain more keys on his side.
So the
I mean,
the log server doesn't make any statement about the archive. It only says, yes, I have seen this release file. So the log server doesn't do any inspection or anything. The log server serves for us to be sure that we have a globally unique view, so that there can be no release files that we don't know about, for example. Does that help you? Not sure. Okay, yeah, we can go back to that later, or perhaps you can ask your question in another way, so I can perhaps try to give a better answer to you.
You said you're already running your own log server, and can you say something about the resource requirements, both in bandwidth and CPU and memory and disk and all of that?
So what I've done previously is I've used 2 years of stretch during that was mostly during testing, and that resulted in a disk usage of the log server of 390 gigabytes or so. So that's 2 years during testing where packages are added. I took the data from snapshots Debian.org and basically replayed it. So that's, well, it is disk space, but it seems to be a manageable amount. The log server accepts only write requests or submissions from the archive, and well, my log server now from the mirror. But in the Debian case, it would only accept write access from the archive. So that's not a huge problem for us, because we assume the archive is not going to try to DOS the log server.
Yeah, I was thinking more for on the client side, in terms of bandwidth and CPU and so on.
Yeah, okay. So the clients, we would probably try to make work in the following way. So I mentioned here that the clients do 2 checks. They check that the release file was included in the log server, and they check that the log history is not committed. So this one is called a inclusion proof, and the second one is called a consistency proof. And they all are just a list of tree hashes and signed tree roots. So another hash value and a signature, and the tree size, some meta information. So this is all in the few kilobyte range, each of these proofs. So the way that I would want to do it in the moment is when the archive submits something into the log server, it also retrieves the proofs that the clients are going to need and puts them on the mirror network. And we can So for each release, we would have one of these inclusion proofs, and we would need consistency proofs. How many consistency proofs depends on how far we want to be able to go back, basically. So how many mirror pulses do we want to be able to go back? And if we say a year, that's 360 times 4. So that's the number of consistency proofs that we need to provide. So like I don't know, 2,000, 3,000 or something, I think. Yeah.
Is the 350 gigs or whatever the number actually was, is that all architectures or a single architecture?
It's metadata and source packages, so we don't store binary packages. The reason is that here we assume all packages are reproducible and we can use, we can rebuild. Yes, yes, yes.
That's a pretty big assumption, but yeah.
Yes, yes, yes. Sure. We are looking forward to the future. And we can rebuild and check that the hash of the binary package matches. I mean, for starting out, of course, first the archive needs to be rebuilt so that we have the build info files to rebuild everything, and then we would, of course, have to start out with a blacklist or a whitelist of packages that we can check in this way. Yeah.
Will the size of that forever be growing, or are you looking at doing rotation on a per release basis, for instance? Because I mean, 350 gigs is by itself might not be a problem, but when it grows into terabytes and terabytes, it's kind of annoying to shuffle around.
Yeah. So I don't have a specific or a specific proposal to do that. The thing they do in certificate transparency is they have log servers for different years and then keep the old ones frozen and switch the submission to the new log server. So something like that could probably be done, but needs some additional logic. Yeah, but I don't have a super specific proposal to address that. Yeah.
Okay, thank you.
Is somebody watching the IRC? Is anybody in IRC asking something? Okay. Yeah. So if you don't have any questions right now, I could quickly tell you what the implementation looks like right now. So as I said, there's a mirror that provides these proofs. As I mentioned, they could be output by dark. I'm working on dark patches to do this log submission. Unfortunately, I haven't finished those yet. And there is the log server, of which I've already done one rewrite because it turns out not all the ideas I had in the beginning were super smart. The main things that are missing are apt integration. So we would need to teach apt, as I see it, two things. First of all, we need to teach it to retrieve additional files which are not covered by the release file, because the proof files cannot by definition be covered by the release file. That's one thing. And we would need a mechanism in apt to do an additional verification. For example, by extending the JSON RPC interface such that it would also be called when a release file is downloaded. So we could, for example, first do the usual GPG check and then afterwards check the log proofs. Or use the JSON RPC interface to have the log proofs checked, and then depending on the result, success or failure, have the release file accepted or rejected. So that's one thing, and the other thing is the the monitor component, which is responsible for investigating all this stuff. I have a prototype that does all the cryptographic verifications and a bunch of analysis of the metadata produced by the archive, such as were all versions correctly incremented at all times, is a source package available for this binary package, and so on. But that needs to be done for the current log server implementation. So the older prototype needs to be redone for the monitor. Yes. we have a question from IRC.
If you're storing source packages, does this break if one has to be removed? For instance, if it is found to be illegal for copyright reasons?
Yes, so the current implementation does not do that. The way that we would do it is to remove it from the log server, or just have the log server not offer it for download, and then put into the log server a statement that this leaf of the tree had to be removed, so that the code doesn't choke on it, and we have logged the and then we have documented the fact that it had to be removed. Yes, I think we do have a little bit more time. 5 minutes.
When do you expect this technique to be to make its way into Debian?
Well, that's a good question, because it depends on really many people. So FTP master needs to be happy with doing the submission. Presumably DSA needs to be happy with running the log server, and the apt maintainer needs to be happy with the way that the verification is done. So
what's the estimate?
I don't know.
What do you hope for?
Well, so from my point of view, it also depends on how much progress I'm making with the programming of the components, because well, they have to exist first, such that I have a proposal that people can suggest improvements to.
Okay.
Yeah. Yeah. Another question?
So what if you would just extend apt to have some kind of distributed blockchain, so that the apt clients would compare what are the hashes of the release files they have been downloading, and maybe add that to some global blockchain,
Yeah, so
instead of having a separate log server?
There are proposals that go into this direction, if you're interested in that. So I think the work is called Contour. I don't have the exact citation here, I'm afraid, but I think you will be able to find it if you look at that. So the reason why I didn't follow that approach in the design is that it needs all the apt installations to run networking code that does lots of things. They need to communicate a lot with other apt clients, and these are all things that are not done today. So basically, I have tried to use the lowest complexity approach, and also for all things blockchain or distributed, if you have proof of work that presents a whole problem by itself, because you need to consume energy in order to achieve security, such as providing the globally unique view. And this is something that we can achieve without spending this energy, by using this more centralized approach, which also fits well with the model that distributions work in, right? Because we already have a centralized archive with a CDN. So adding another central component works, I think, really well. Okay, so
question on IRC channel. Given that the point is not to have archive and log be compromised together, would anyone but DSA be better? Can there be multiple log servers? M. Palmer asks.
So the that's an interesting point. There can be multiple log servers, and the approach that I'm hoping for is the following. So in the case that the log server tries to present different views on the tree in cooperation with a malicious archive, right now in the design I presented, this kind of attack would work, and we couldn't do anything against it. And I think the only way to get around this is if there is a third-party run log server, for example, involved. That's not compromised, right? If we assume one organization's administration team is compromised, then all the servers run there can be compromised. So we need something from the outside. And what I'm hoping for is, by the way, in certificate transparency, this problem isn't solved as well right now. So there are several proposals. I also have some proposals. And the one that I'm hoping for is that we can perhaps once certificate transparency logs are going to solve this problem, that we can use the solution. So certificate transparency logs aren't usable for our purpose for a number of reasons, but my hope is that for the purpose of defeating this kind of attack, we can actually cooperate with them. And the way that it would work is that we have our log server submit the tree roots into a log server that just accepts tree roots from logs and serves the purpose of detecting these kinds of split view attacks. So that's one of the ways this is possible to solve. Another one is to have the auditors or the clients exchange tree roots with a monitor, and then these two could be would be able to detect that they were presented with a different history of the tree, and could detect that fact, and also already have the proof that the log server was malicious because it has signed two tree roots that are incompatible with another, where one is not does not cover a subset of the other. Yeah. So thank you very much. It was very interesting to me. I hope certainly you brought up some good ideas. I hope you understood a bit better what we are trying to achieve here. We have to close this session now, but do feel free to come to me and talk a bit more about it. Thank you.
Thank you.